This is Dr. Obulakonda Reddy, Department of Cybersecurity. Now, today we will discuss on a cluster computer and its architecture. Coming to this is a starting step. I collect from sources from these textbooks and as well as these slides. I've taken the references. I collect the information from these sources. Now discuss with the cluster and computer architecture now. A cluster computer and its architecture. First is the definitions. A cluster is what is a cluster? Now coming to the topic here, a cluster. A cluster is a type of parallel as well as the distributed processing system, which consists of a collection of interconnected standalone computers, and these are all cooperatively working together as a single system, integrated computing resources. So this is called as a cluster. Cluster is nothing but a group of systems that has to be combined with a different nodes of a system, which act as a single system. So as well as the integrated computing resources also. So working together as a single and integrated computing resource. Now see here, what is the node here? So what is a node? Node nothing but a single system in a cluster. So a single or multi-processor system with memory, I/O facilities and operating systems. So a node consists of either single or multi-processor system with memory, I/O facilities and operating systems that contains generally two or more processors, which is called also node. Two or more processors connected together. And other thing is, in a single cabinet, a physically separated and connected via LAN. So all nodes interconnected with a LANs now. So now, for example, in a cluster systems, we have 100 of systems now. To system, assume that each one is considered as a system. Now, so interconnected. So in between each system, we have to each node connected with each node. It should have connected with a LAN and high-speed networks. In between, it contain as a LAN, local area network connections, as well as the. So now that is the thing. In a single cabinet are physically separated and connected via LAN. Through a LAN, all systems are connected here. Appear as a single system to users and applications, but it is appeared as a users. In user perspective, this is total cluster system has to be appeared as a single, either user perspective or application perspective. Both views, it is total cluster is appeared as a single system, but internally it have a different group of systems. Each node which has to be contained as a different nodes. Node nothing but a single systems that have contained as a that have contained memory, I/O facilities and operating systems. And last thing we have discussed with the last thing now, it is provide a cost-effective way to gain features and benefits. So this is a cluster computer and its architectures. In these things we have discussed with what is a cluster definition. Initially we see with what is the definition of a cluster, and the second thing, what is a node? Node is one of the system in a cluster. Now this is a overall diagram now. So first, initially high-speed network or switches. Now we focus on this one. Initially see here, this is called high-speed network switches. It has to be PCR workstations. So each one is considered as a node. First node. Assume that is the first node, second node, third, fourth, fifth, and so on like this. So these are all the different nodes that has to be interconnected with a high-speed network or switches. And first one. So each node contain as a PCR workstations, which has node, and communication software in between from new network interface hardware. So this is in this node which contain as a hardware and the communication software. It has to be interacted with a PC, whatever the user is given task, that has to be interacted with a hardware. So every node is contained like this PCR workstation. Each one is considered as either PC or workstations. So this is, I am telling about that in a cluster system, it has a group of systems is there. So now second system, PCR workstations, it is also communication software. and hardware. So the software which has to be interacted with a hardware and it has to be processed. Again, it should be written to a software. The software will be given to users. That details has to be given a users. So these are all the nodes 1 to 5 here now. These are all the different nodes that has to be interacted with a cluster middleware. So single system image it is the availability of infrastructure. So now a cluster middleware. In this middleware, it has to be interacted with a group of nodes or PC workstations. And then after that, it has to be sequential applications. We have given a different applications to a cluster systems. It has to be maintained like this. All applications are maintained in a queue like this. These are all the maintained different applications. Sequence of applications are maintained to here. Then after that, in these stages, now right side you observe that parallel programming environment. So it is to be created with a parallel programming environment, parallel applications like use of different parallel application tools. Then taking one by one sequential applications, taking one by one, it is given to middleware that will be assigned works to a PC workstations, and then it should be a completed those sequential application tasks. So this is a process has to be happened in. This is a process happened in this total diagram, cluster computing systems. After this, once it has to be completed, it has to be interacted with a high speed network or switches. High speed networks are switches. So it is interacted. Then later it should be sent to a other sharing to a information to other systems. Now we are focused here. Nodes are nodes internally the PC workstation. This is each one considered as a PC workstation that have a one software and that internally have a hardware. So now these systems as interacted with a cluster middleware. Above the cluster middleware, different sequential applications like different tasks is existed now. The task has given to a parallel. Parallel means that same time it has to be executed. 100, for example, we assume that we have a 100 systems is there. That 100 systems parallelly in the sense it has to be taking the 100 tasks at a time, same time, take the all tasks at a time, and then it has to be a parallel environment, created a parallel environment that is interacted with a middleware, cluster middleware. Then each system, 5 systems is there, 100 by 5. Total task is divided to these 5 nodes. So after this process has to be completed, it has to be sent with a sharing a data. Then it is used a high speed network or switches. Then it has to be sending data to a network. So this is a process happened in a cluster computing. This is the way we have to perform the cluster. Now see here, prominent components of a cluster computers. First we discuss with a stage 1. In a stage 1, multiple high computers. It is required for we have observed here. So first stage 1. Like prominent components of cluster computers. So what we have to create it with a cluster computing. First way, it is a multiple high performance computers. For this one, what we have to take in. So these are all the parameters now. Personal computer, PCs, then workstations, SMPs, and distributed high performance systems leading to meta computing. So these are all the these are all the things it has to be required with a components 1. So prominent components of cluster computer. So initially we are created with multiple high performance computers. For this, actually of this one, then personal computers, workstations, we have created with a personal computer, workstations, symmetric multiprocessors, SMEs, symmetric multiprocessors or clumps, and then distributed high performance systems leading to meta computing. So initially, this is a stage 1 we have to create it with a multiple high performance computer. Achieve of this, then we have to use these things. Then take for second one, state of the art of operating system. So here now prominent of components of cluster computers. Now we take as a 2 in the stage 2. What are the prominent components of cluster computing? Stage 2. Then take for the state of the art of operating systems. In case if you use Linux, then this is a system we use, and then Microsoft ENT. This is the illness HP VM virtual machines. Then Sun Solaris, which has to be used Berkeley now. Other thing, IBM AIX, that is use IBM SP2, Service Pack 2. And then take this is the other systems, Unix environment, Illness Panda. And then Mac, so microkernel based operating systems. This is written as CMU. And then next, cluster operating systems, like taking as a Solaris is MC. SCO, Unixware, Mosaics. So next, operating system gluing layers, that is Berkeley GlueNex. So these are all the requirements. Now state of the art, the operating system has play a key role uh, in the cluster computing. In this one, it has to be use the different operating systems. Like for example, Microsoft NT, that is illness XP virtual missions, high performance virtual missions. And in case if you use Sun Solaris, that is a Berkeley now. So this is the stage 2 we consider with a state of the art of a operating systems. And see the third stages. We see with the third stages, high performance network and switches. In the previous stages we discussed with the operating system. What are the operating systems to use? In these stages we use network, high performance network and switches. What are those? Ethernet. Ethernet used to up to 10 Mbps, and the fast Ethernet that will be taken as a 100 Mbps. Now gigabit Ethernet that maybe takes to up to 1 GB per seconds. Next, SCI. So that will be Dolphin MPI 12 microseconds latency, and the ATM MyraNet 1.2 Gbps, and digital memory channel FDDI. So these are all the help for the network switches, high performance for performing in cluster computing. The networks are switches performing in high performance given at a cluster computing. Then we use this networking component: Ethernet, fast Ethernet, gigabit Ethernet. So SCI, ATM, MyraNet, digital memory channels, FDDI. These are all the things we consider with a fast computing components of a cluster. In the fourth thing, what are the prominent components? In the fourth point, we'll discuss with a network interface card. This is also important to in a cluster environment. MyraNet network interface card. So in the network interface card, that is simply write as NIC, network interface card. Then MyraNet to use user level access support, which has to be used for a user level access support. MyraNet as NIC, network interface card. In the fourth stage, the component will take as a NIC will take MyraNet, which is supported to cluster computing. And next one we will discuss with the fifth one, fast communication protocols and services. What are the things supported with a fast communication protocols and services? So first thing is a active messages. So we want to send with the active messages Berkeley systems. Then active messages Berkeley systems to use. Then fast messages active, and fast messages Illinois. Next, UNET. UNET means this is also one of the fast communication protocol. Then kernel that has to be used with the kernel. XTP. Then this is the thing that has to be used. So fast communication protocol and services. For this issue of this one, we have to use for this active messages, fast messages. This is the fifth prominent components of cluster computers. And sixth thing, we see the six things here. Cluster middleware. In the diagram previously, we have seen one diagram in cluster middleware that has to be interacted between node and sequential applications. A parallel, whatever you send a parallel application in between, cluster middleware is there. So in the cluster middleware, we want to create it within cluster middleware, single system image, SSI. We have to create it with a SSI, single system images, and system availability, SA. That is the very important system availability infrastructures. In the cluster middleware, always we have to focus these two things now: single system image, system availability. Anywhere, in case if it is any one of the system fail, it has to be alternatively we have to create it for a different systems. It is not to stop a total work. It has to be assigned works to a different systems. So that is called a system availability. Always the ready to, if it is given a work, that is always to ready given to do the works. So for that one, we have to see a system availability. And then single system images. So single system images, whatever we created that in a single SSI, single system images. So we have to maintain in a SSI and SA. Both these two things has to be, both things has to be created with a cluster middleware. And what is the hardware here? In a diagram, we will see the hardware also. In node, that is the hardware. So that is a physical component of the system. Now DEC memory channel that contain DEC memory channel, DSM and SMP techniques that internally use a hardware, internally use DEC memory channels, DSM and SMN techniques, SMP techniques. And operating systems, kernel and gluing layers. So Solaris is, for example, in operating system, it is intermediate between user and a hardwares. So now operating system, so use Solaris MP, Unixware and GL Unix. And applications of subsystems, like we have taken what are the applications in a subsystems. What are the applications? System management and electronic forms, and runtime systems like software DSM, PFS, etc. Resource management and scheduling softwares, RMS. Resource management and scheduling software. So for that one, coding, LSF, PBS, NQS, etc. That has to be used in the 6 stages. Prominent components. So one is a cluster middleware, SSI and SA, that has to be maintained in a cluster hardware. Cluster middleware. Hardware. In the hardware, DEC memory channel has to be used here. Operating system, kernel and layers, Solaris MPs, MCs, Unixware, and GL Unix. And applications of subsystems are applications, system management and electronic forms, runtime systems, and resource management and scheduling. So, resource management. What are the resources? Like a printer. A printer is one of the resources. We given a printing, that is one of the resources in a cluster. Scheduling. So, given jobs has to be maintained in schedule. Which one is executed first? Some scheduling use a scheduling algorithms. Then we have to execute it for first. Which one has to be executed? If you given 100 of tasks, so which one out of 100, which one scheduling, like in what time it has to be executed. So that is comes discussed with the scheduling software. Under this one, we study with the different algorithms also, RMS. And next one, prominent components. In the prominent components 7th, what are the prominent components of a cluster computers? Other thing is a parallel programming environment and tools. So in a parallel programming environment and tools, which has to use thread. Thread is a small lightweight process that has to be executed in a system. Now in this one, threads, PCs, personal computers, symmetric multiprocessors. Now, so in this one, etc. So in these systems, the threads has to be executed. POSIX. Now the threads has name POSIX threads and Java threads. That two threads has to be used in a parallel programming environment. Parallel in the sense at the same time the task has to be executed. So MPI, for this MPI, Linux systems, NT, and many supercomputers has to be executed. PVM and the software DSMs, compilers like C compiler, C++, Java. Then parallel programming with C++, that is MIT. Parallel programming with C++, that is also executed. RAD, Rapid Application Development Tools. So in this one, GUI, Graphical User Based Tools for parallel programming mainly. And next one, debuggers. Bug means errors, debugger, correcting errors, debuggers, correcting errors. And then performance analysis tools. So how after execution of the programming, how the performance will give it here. So visualization tools. Once we have to complete those things, how the visualize, like how many, like it may be showing with a graphs. What are things are existed with. So these are all the things supporting with a parallel programming environment tools. Threads. One is a thread MPI, PVM. Next, software DSMs, compiler, RAD, Rapid Application Development, debuggers, performance analysis tools, visualization tools. These are all which has to be supported with a parallel programming environment and tools, which is given at a prominent tool for a 7. We want to create it with a cluster computer. Then these are all the components we have to take considerations. Now 7th is now discuss this thing. Now 8th thing, what are the applications? So what are things of the applications we have to consider here? Sequential application. Sequential is nothing but it has to be executed one by one. Then parallel or distributed, cluster aware applications. Parallel or distributed environment. At a time, all tasks has to be executed here. For example, sequential in the sense, for example, assume that these are all the systems one by one. 100 tasks, it takes for a 100 tasks. Then it takes for one by one executed. Each one will take as a 1 second. Then 100 seconds will consider with this. Then in a parallel or distributed environment, which has but a total system has appeared as a single, but it have a different systems. For example, 5 systems, 100 tasks will divide parallelly will divided with a 500 by 5. 100 by 5, that is 25. So 25 tasks is given to each system parallelly, which has to be executed. But almost it compared with a sequential system, this may be a less amount of time. All tasks has to be executed. That is performance, high performance. Now, grand challenging applications. What are that? Once you have created with parallel or distributed systems, cluster aware applications, then what are things, what are the applications, challenging applications, weather forecastings. We want to find tomorrow's weather forecast, tomorrow's weather by today. So that is the achievable with a high performance computing, weather forecasting, quantum chemistry, and the other thing is a molecular biology and engineering analysis like simulations tools, CAD/CAM. So different engineering analysis, research things that are the research that has to be used with a high performance computing systems. Now, etc. We have to consider it. Then PDBs and web servers, data minings. These are all the challenging tasks for our parallel distributed. So now this is a prominent, now 8 prominent components of a cluster. Then what are the key operations? So up to this point, up to the 8 prominent components, use of these prominent components, we have to create it with a own our clusters, cluster computers. These are all the 8 things. Now we'll see what are the key operational benefits of a cluster. So what are that? It is given as a high performance. So high performance. So always the system should be, once you have created with a cluster environment, once you have created with a cluster environment, cluster is nothing but it is a different nodes. It is appeared as a single system. Then high performance, whatever your task is given, that will be a less amount of time that should be executed. So the performance should be high performance given its cluster computing, and expandability and scalability. So this is a important thing. Mainframe, compared to mainframe, it is failure of that. We don't extend that mainframe systems. But if you consider with the cluster computing environment, for example, it is 1,000 systems. I want to go for a 10,000 system. Then it is a expandability is also there. Now total it has to be extended up to 1,000 systems. Then 1,000 system we have to be created. So that is a 1,000 to, I want to expandability 1,000 to 10,000. Then it is a expandability and scalability. We want to increase the systems also. So that is the one of the benefit in a cluster computing. And high throughput. This is given. Number of jobs completed for 1 second. So that is a throughput. Number of jobs completed for a particular amount of time. So that is a throughput. So high throughput. So once it is increases the total systems, the throughput performance is also given as a high. Per seconds, it is executed for a more number of jobs. And high availability. This is very important. Availability in the sense, for example, we have considered with a 10,000 systems. But failure of a, for example, it may be failure for a 10 systems. But it is not affected with the other systems, not to affected with the total systems. But whatever the failure systems, the task will be assigned with a different systems. So that is anytime, that is availability of a systems. So these are all the major key components regarding about a benefits of a cluster computer. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.